Hello, and hopefully you've got something in front of you. I cannot get the PowerPoint slides working properly. I've just spent the last half an hour since the last video trying to get it to sort of working. It was a race against time because I'd already advertised the live stream, so I've got myself in front of a PowerPoint slide at the moment, and hopefully if I change it to that would be slightly, hi Zach, it'd be slightly better. So I'm hoping right now you can see me in front of my PowerPoint slide. It's not perfect, but it will work. What I'm hoping to do today is talk about the higher tier level, the GCSE level of what the maths, some of the maths that is going on, and the things you might have heard being talked about in the news, and what is really going on. I'm unlikely to talk for the whole half an hour because it's a topic that I don't want people to be depressed about. It's just the math side of things is quite relevant to a lot of the things we're doing. So I want us to move on, and hopefully you can bear with me because my transitions are going to be terrible, because in order to do things I'm going to have to hide myself on the screen, which is not going to be working very, very well. So I'm not going to be very present in terms of looking at me. So breathing in, this is me. But what I'm going to try and do is have a screen in front of you that is going to be useful instead. So, on that, let me just very quickly transition and delete. That's not what I hope to do. I deleted the wrong bit. So, you're going to have to bear with me. This is not what I hoped to do. Apologies about this. Right. And you'll have to forgive me for a second as this goes to there. And I'm hoping you can now see. I do apologise. That wasn't very smooth, but I'm having a few technical difficulties that we will conquer as soon as possible. So, compound growth and decay. Basically, mathematically speaking, you've got the disease itself will spread with a multiplication factor that increases day on day. What this means is every single day you can multiply the number of people who've got the disease by a certain quantity. Now, people have been talking in terms of 3 people is the average number of people infected by someone with the disease. Now, that means one person will infect 3 people will infect 3 more, which is 9. 9 people will infect 3 more, which is 27. To show that, I've assembled this sort of diagram. So one infected person appears in this whole sea of people. And that one person, on average, will come into contact and spread the disease, because it is possible they'll come into contact and not spread the disease, because we have to bear in mind that first person will not likely know that they've got it for 5 days. It's going without symptoms for 5 days, and that's what's making it so dangerous. When it gets multiplied, 3 more people can become infected. It might be that they've bumped into them, it might be that they've got too close to each other. So we've gone from 1 to 3 more. That's a total of 4, as we know. But it's 1 and 3 more. Now, we're saying that one person is on average going to infect 3 people. We don't know the time frame. So I've now got 3 more people who've become infected. This first person was infected. That means on the next day, we have 9 more people. Or next series of days, 9 more people, because those 3 that got infected have gone out and on average have infected 3 more each. Now, obviously, it's an average. Some of these people might have been self-distancing, but we're looking at the model here in terms of what is happening if people aren't staying checked, if people are not looking after themselves. At the end of this point, maybe that first person got better, but one of the people they infected was elderly or had asthma or was in a high risk situation, and they have unfortunately died. So you've got the one person who's got better and we think now can't get the disease, but the multiplication factor makes it so that the one has disappeared. That now means we now need to grow, and there's more. And you'll notice this is just a small sample, but already it's becoming very, very crowded with people who could be potentially infected. Once again, 3 people might recover, but 1 or 2 could die or get seriously ill, and we've had 2 people disappear. Now, the reason this is a dangerous thing is because we need people to realise that it's not just about them, but as society as a whole. That's 3 people in this sample set, and this sample set has only got 6 times 10, 11, 66 people in it. 3 have sadly gone. Now, these are fortunately circles, and I'm trying to use it as a simulation to show people what's going on. Now, mathematically speaking, I did say I would talk about the multiplication factors of that. So, if you'll bear with me a second. So what I'm just trying to do is get it up so that I can talk to you, and this is going to be the easiest way to do so. So what this is saying is that the multiplication factors really influence the things that are going on. They really influence the number of people. For example, at the moment we're looking at the powers of 3, the powers of 2, and the powers of 1.4. 1.4 has been plucked as what we're trying to aim for, or a reduction that would be really, really good. If everyone infects 3 people, we just did the sums involved in this. It's a multiplication, but it's a power. So it's times 3 to the power of n. And we call these exponential functions. 3 to the power n is going to be, after one day, it's going to be 1 and 3 more and 9 more and 27 more and 81 more and 243 more. That number gets very big very quickly. And this is only the 5 days while number 1, that one person who was infected, was trying to sort themselves out and didn't even know that they were ill. If we can get that down to people only infecting 2 by social distancing, by making sure that people stay apart, that 1 gets added to 2 and 4 and 8 and 16 and 32. That 5 days, that is a lot of people who have not been affected. If you can imagine that 5 day, if we could get that down to people who are only infecting 2 people, then that is a big change. The next one is 1.4. That means 1 would only have 1.4, and we can do it on our calculators by doing 1.4 times 1. That stores 1.4 in our calculator. What I'm going to do is times 1.4 again, so we can see the increase is 1.96, and again is 2.744, 3.8416, and 5.37824. That is the new number of people each day. 5 new people by day 5 is very different from 243 new people using if we don't do anything, if we don't do the social distancing. Now, obviously, if everyone social distanced, this wouldn't be a math problem anymore, because as soon as you put everyone in a box and they can't get to each other, then there's no social distancing, there's no maths involved. It stops. But that's not the case. We have to have people going out shopping, we have to have our key workers, we have to have all the important people helping us out. Now, the second thing I was going to talk to you about is, with this growth, is the fact that you can have exponential graphs. Exponential graphs are graphs where you can it's the y equals 2 to the power x. So y equals 2 to the power 10, y equals 2 to the power 40. It shows the graph. Now, I have hoped that I'm going to be able to get this working so that you can see exactly what I can see. We will see if indeed that is the case, but I'm hoping there's always a chance that I will be able to get this screen loaded, and if it is the case, then you will be able to see what I can see. And right, we'll back off that for a second, because it's unfortunately not working the way we'd hoped, and I'm trying to make it so that you can get the best learning possible. I hope people are being very, very understanding of the fact that it's let me down today. About halfway through my live streaming, this just goes to show what happens when you're learning. I'm going to have a very brief pause while I flick into something, and hopefully this is what we're talking about, the powers of 2. This is the graph I was talking about. So the green graph is at its steepest. You will see the green, blue and red graphs are all very similar. They all end up shooting up by about 8, 9, or by about 10. They've all disappeared up at the top over 500. These are the graphs of y equals 3 to the power x, y equals 4 to the power x, y equals 2 to the power x, and y equals 1.4 to the power x. Now, what they talk about in the media is they're talking about shallowing the curve. The reason being, on the red curve, you have got 8 days to try and treat those 250 people so that they're not infecting as many people. You've got 8 days longer to try and identify people who might be ill and get them away from people. You've got 8 days longer. This is still going up and up and up. More and more people. But you can see from these graphs, and these graphs, exponential graphs, start low, gradually move along, and then go up. And they always take the form of a number to the power of another number. You can see down by 0, they're super, super small. And they're also go off, they start at 0. Or 2 to the power 0 is 1, so start at 1. We always start with that one person who's starting it all off. But we can see why there's a big problem if by 4 it's already at 260. That's a huge problem, and that's the maths behind what's been going on. That's why people have been talking about the different things. Now, I'm hoping this makes sense to people. Abdullah, this graph is just supposed to show the fact that if I do 2 to the power 2, I get 4. You can do that in your calculator. And that's why it's way down low for 2 to the power 2. But 2 to the power 10, if you were to put that in your calculator, 2 to the power 10 is 1024. Hence it's disappeared, but we don't even get to see it on 10. In this graph, all you've got is an input and an output. So therefore, the number that's going in along the bottom and the number coming out becomes astronomical in an exponential graph. Now, all of these numbers going in, when they come in, we want to shallow it and make it last as long as possible. So what this live stream is about is just about the fact that with the coronavirus, we want to make those numbers less and less. Now, with the diagram I showed you earlier, this is what would happen if you've got everyone isolated. On the left, we can see all the people are in their own homes. They're not going out and communicating with each other. So even though that one person is in the house and is infected, there's only one person they can infect. Now, I know that this is an ideal world because we've still got things like people going out to the shops and things like that. But it cannot infect each other. Whereas on the right-hand side, we've got a person who's out and they're still going out playing with their mates or going to a barbecue or running around with each other and they're interacting. That's going to be the same as the very first diagram we did, the very first example we had, where one got infected and then another 3 got infected and then another 3 got infected. So, just hope that this little bit of maths, it's only been about 20 minutes, I believe, but enough just to go through some of the GCSE higher maths side of what's going on. The exponential graphs, the powers, and the fact of how those things interact with each other. There is also percentage change and also a compound interest. When we talk about compound interest, you've got this idea that if you have, for example, £1,000, you can multiply it by 1.04 and that'd be 4% per year. Here we've got a multiplying factor of a percentage change. Let's say every day we get 3%, it get 30% more people. So we might have one person, and that gets times by 1.3. Day 2, 1.3. So nothing much has happened there. But then if we use this compound interest example, we can do one person times 1.3 to the power 25 days. Let's see what's happened in that 25 days. Maybe make a prediction, what you think has gone on here. Where will it have gone? 1.3 to the power 25. Well, in 25 days, that's 705 people infected. 705 people infected because that one person didn't keep themselves isolated, and that's if we have 1.3. That's 30% more per year. Okay, 30% more. So it's important to realise the difference. Okay. Now, I hope that's been useful and interesting. I know it's not my best video. Unfortunately, the technical difficulties made it impossible. I had other stuff that I was going to be doing, which I can't do because it's just too awkward. Thank you very much for joining me. I hope it's made some sense. I will make sure that tomorrow's video is even better than this. From next week, the higher videos, I'll be trying to do 2. One on the Monday or Tuesday, one on the Thursday or Friday, but making them quite a bit fuller and with a range of different materials. So please get in contact with me and email me with the things that you'd like covered. I will quickly transition to me. Hello. Please email me with the things you'd like covered. So over the weekend I can prepare. What I'm going to try and do is, rather than doing every day and having not many people interested, I'll try and do one in the start of the week, one at the end of the week, so you can tune in for the higher tier GCSE stuff, and I'll try and make it cover a couple of bits and make it a bit longer, but a bit more planned, a bit more prepared. This was really planned, but unfortunately PowerPoint has just let me down today, so I'll be spending a bit of this afternoon trying to work out why it hasn't been working and see if I can resolve it. Thank you very much for joining me. I really appreciate it. And if there's any questions, put them in the chat, and I'll go on a bit more about that in the end of the live stream. Thank you very much, and I'll speak to you later.